After just 12 hours without water, your blood begins to thicken. After 24 hours, your kidneys struggle to regulate electrolytes. By 72 hours, organ failure becomes a real biological possibility. Hydration is not simply about thirst. It is fundamental to cellular stability, circulation, and neurological function. So what actually happens, physiologically, neurologically, and systemically, when you stop drinking water for 3 full days? Water makes up approximately 60% of the adult human body. Blood plasma is mostly water. Every cell depends on it to maintain structure, regulate temperature, transport nutrients, and remove waste. Hydration maintains blood volume. It stabilizes blood pressure. It allows electrical signaling in the brain. It enables kidney filtration. When water intake stops, the body does not immediately collapse. It adapts. Within the first 6 to 12 hours, plasma osmolality begins to rise. This means the concentration of sodium and other solutes in the blood increases as fluid volume decreases. Specialized receptors in the hypothalamus detect this change. In response, the posterior pituitary releases antidiuretic hormone, also known as vasopressin. This hormone signals the kidneys to conserve water. Urine becomes darker and more concentrated. Urination frequency decreases. Thirst intensifies. At this stage, the body is compensating effectively. By 24 hours without water, dehydration becomes clinically measurable. Total body water may decrease by 1 to 2%. Blood volume declines. Heart rate may increase slightly to maintain adequate circulation. Sodium concentration in the bloodstream continues to rise, leading toward hyponatremia. Through osmosis, water shifts out of cells into the extracellular space to balance sodium levels. Brain cells begin to shrink slightly. This cellular shrinkage can produce headaches, difficulty concentrating, and irritability. Cortisol levels rise as dehydration activates the stress response. The sympathetic nervous system becomes more active. Blood pressure may fluctuate. Standing up quickly can cause dizziness due to reduced plasma volume. The mouth becomes dry. Saliva production decreases. Swallowing may feel uncomfortable. By 36 to 48 hours, compensatory mechanisms begin to strain. Kidney perfusion decreases as circulating blood volume drops. Glomerular filtration rate declines. Waste removal becomes less efficient. The kidneys attempt to conserve every possible drop of fluid, further concentrating urine. Electrolyte imbalance worsens. Sodium levels may rise significantly. Potassium regulation becomes unstable. Muscle cramps can develop due to disrupted ion balance. Sweat production decreases dramatically, impairing temperature regulation. The body becomes less capable of dissipating heat. Core temperature may begin to rise in warm environments. Cognitive function declines further. Confusion, fatigue, and slowed reaction times become more pronounced. Blood viscosity increases as plasma volume decreases. Thicker blood requires greater cardiac effort to circulate effectively. The heart compensates by increasing rate and contractility. By 60 hours, total body water loss may exceed 4 to 5% in some individuals. At this level, dehydration is considered severe. Hyponatremia can lead to neurological instability. Neurons rely on tightly regulated sodium gradients to generate electrical impulses. When sodium concentration rises excessively, neuronal signaling becomes erratic. Agitation, disorientation, and impaired coordination may occur. In extreme cases, seizures are possible. Kidney injury risk increases substantially. If renal perfusion drops below critical thresholds, acute kidney injury can develop. Urine output may become minimal. Blood pressure may fall dangerously low as vascular volume collapses. Circulation to vital organs becomes compromised. By 72 hours without water, survival depends heavily on environmental conditions, baseline health, and activity level. In moderate climates, a healthy adult may survive approximately 3 days without fluid intake. In hot environments or with physical exertion, survival time can be dramatically shorter. Severe dehydration, typically defined as greater than 10% total body water loss, can lead to shock, multi-organ failure, and death. But the body does not fail all at once. It sacrifices peripheral systems to preserve the brain and heart. Skin becomes dry and less elastic. Urine production nearly stops. Blood pressure becomes unstable. The organism shifts from regulation to preservation. Water is not simply a nutrient. It is the solvent in which every biochemical reaction occurs. ATP production depends on proper hydration. Electrolyte balance depends on water distribution. Neural transmission depends on osmotic stability. Without water, systemic equilibrium collapses from the cellular level upward. The danger is not thirst. It is progressive internal destabilization. After 72 hours without water, the body is no longer compensating efficiently. It is entering physiological failure. The human body is remarkably resilient, but it is not independent of water. The real question is not whether you could survive 3 days without drinking. The question is, how often do you underestimate the importance of hydration? And how close are you, right now, to mild dehydration without even realizing it?